Hello grade 12, welcome to my channel. Hope you guys are doing well and you've been practicing. Let's give you yet another push in the direction of sequences and series, okay, so that you guys are ready for your term 1 exams. Of course, I'll try to do a full paper for term 1, now this time taking it from the beginning to the end so that we can sum up all that you need. Of course, I'll choose ones that cover the topics that are stipulated in your ATP as part of the term 1 examinations, okay? So this paper was from the Northwest Trial last year. We're going to focus on question 2 and question 3, which is sequences and series, so that you can appreciate this. I'll leave the other sections for later. I will do this question paper at a later stage, okay? So I got it from essay exam papers. It looks like some academy submitted this, whatever. So let's look at this question 2 nicely and go on with it as best as possible. Okay. So the question reads, consider the linear pattern. Now what is this pattern? Linear. Okay, so once it's linear, we know that it's arithmetic. There's a common difference between the two. And in fact, there's a common difference between any two consecutive terms because of the signature that it is linear, okay? So we know that this is an arithmetic progression from 4 to 10 to 16, and it continues like that. And we know that if this is an arithmetic progression, the common difference is going to be 6 throughout. We don't even think about it. So this, we know, it's fixed. All right, so let's answer 2.1. 2.1 asks us to write down the value of the following term, meaning the next term. So we've got T1, T2, T3, so this is going to be T4, and that's what we want to know. So obviously we add 6 to 4 to get to 10, and we add 6 to 10 to get to 16, then 16 plus 6 is going to give us 22, and that would be the term. So we can write safely that T4 is equal to 22. Now for an answer only, for a 1-mark question, an answer only is good enough, okay? As long as it is correct. But I sometimes like to show this framework in my answer book so that even if somebody is wondering if I copied this, they can see that I actually worked it out, okay? Because guys, we need to avoid giving the impression that we copied. There's people who misbehave in the exams. There's teachers who actually make their students copy. So these kinds of things need to be clarified. There's certain things that can be expected to be done by two individuals the same way. But there's certain things that sometimes differ in how they approach them. So they can't always be everything, just matching exactly the memo the way it looks. Because when that happens, it means definitely there's some chicanery there. Okay, let's leave that for now. So determine the 50th term of this pattern. Easy. Since this is linear, we know that Tn is A plus n minus 1 times d. We derived this formula, and we understand what it came about. So now T sub 50 is going to be the very first term, which is 4. We put 50 where n is, and we put the common difference. Therefore, T sub 50 is, let's put it on the calculator, 4 plus 50 minus 1 times 6. Just plug it as it appears. I'm getting 298. Okay, so that's easy. Again, guys, usually substitutions have to be correct for us to get full marks. Somebody may argue, what if I just wrote the answer only? Is it possible, guys, to work this until term number 50 and not lose the entire time for the exam? I doubt. So in my opinion, it sounds crazy. But some people may know that, okay, if I'm moving from T1 to T50, I'm going to have 49 of these common differences. By inspection, one can say, okay, T50 is going to be nothing but 49 of these plus the first term. So maybe an answer only is justified. We can give 2 marks, but it can be a bit of a situation if you don't know the pattern. But again, we taught it now. I taught you how to look at these things, because I mean, by inspection, you can just easily say 49 times 6, and then to that you just add 4, because these differences are going to be 49 for 50 terms. These are the things that we're going to be adding to the first term. So perhaps an answer only is okay for 2 marks, but we could use the formula, which is the standard approach. Again, using it, you get 2 marks, either for correct substitutions and the answer. So perhaps this is okay, because as I said, by inspection, one could easily say, I know that T50 is going to be 4 plus 49 of these differences. And this is easy. Even if I didn't write the formula or didn't follow the formula, then I would know that this is still 298, okay? So one can easily just do this as a side calculation and write the answer, and that's okay. That's all right. So if you understand these patterns, you know what to do. If you don't understand them, perhaps we might get worried, but be very careful. If we are doing a calculation, what does the instruction say? Wow, this one doesn't have instructions. Goodness, this paper is ridiculous. But remember, guys, it says we need to show all calculations clearly. And you can see this is a calculation. So sometimes not showing it is a bit of a crime, because it says we are not adhering to the rules. So be very careful. As much as there can be some, pardon for not doing what's right, as long as the answer is correct, but you may not be forgiven in a particular environment, especially at nationals. We don't play there, okay? So don't play, guys. In fact, even at a provincial level, we should not allow anyone to play. Okay, 2.3. That's not a big deal. Let's have a look. We are told that a quadratic sequence, what? Quadratic sequence is defined as P sub k equals the sigma of 6n minus 2 starting from 0 to k minus 1, okay? Now, when we look at this, we can see that this whole shenanigan is linear, right? Because this is a linear expression. And we know very well that the sum of the first n terms of an arithmetic sequence, in general, it gives us a quadratic expression, because as we sum up those terms, they behave like a quadratic equation or a quadratic, function. Okay, that makes sense. So it means, yeah, we can accept this. But now here's what we know. For this to be a linear expression, we understand that n is an element of natural numbers. But now we can see that n is starting from 0. Is this fair? Maybe, because the starting point can be flexible, right? Depending on the question. Or should we say the expression given? Maybe to say question is a bit questionable, but maybe on the expression itself. But we follow the natural numbering system anyway. But we can start at 0. It's fine. But here's the problem, guys. The numerator the numerator, this one has to be also an element of natural numbers itself, because we can only sum terms to a particular natural number. That numerator has to be that number at the top also has to be an element of natural numbers. Okay? It can't be an element of other numbers. I hope we understand each other. Now this brings us to saying, if for example we want P sub 1, meaning the first term, this would mean sigma, because remember the K here is the same K as that one, right? So this is going to be 1 minus 1, starting from n equal to 0 of 6n minus 2. Now this brings us to the sigma of 0 starting from n equal to 0 of 6n minus 1. Do you see, guys, that we have a problem now? Because do we ever sum 0 terms in an arithmetic sequence? We never do that. So this is against the standards. It's a good question, maybe, because I have never seen it put like this. But if you just check it nicely with the understanding of what is expected, this already defeats the purpose of making sense. And I know a lot of students are victims of this nonsensical moderation process. I'm saying it that way, guys, not out of disrespect. But you cannot present this to everybody, because whatever you do, you need to have it checked. Whoever is supposed to check is not checking. So now this means, guys, this issue right here, this issue is just pointing out the fact that two people, one, the moderator, two, the quality assurer, are not doing their job. They are just not doing their job. They need to be cancelled because those two people are failing. Now, there's many reasons why they are failing. It could be these ones are junior to the person who submitted this question. So they're afraid of, going hard at them. Maybe it's the person who recommended them for that position. Now, this is why people need to get positions on merit. They must not have someone vouching for them. We need to stay away from these things of the past where you could become something somebody has to vouch for you. This is wrong, people. If we say we are in a democracy, there shouldn't be anything that has to be, because of somebody else. Yes, somebody else can ask, fairly so, not because they are perhaps going to benefit something by you giving that position, or now all of a sudden you don't have to put them to order. No. Some people, like I can, if I see someone who deserves a position, or perhaps to be given a chance, seeing that there's no one else, or at least there's plenty other opportunities elsewhere for others, you can see that this person would not be touched anyway. You could give them a chance, provided you're going to carry them through and teach them and mentor them as well, because you can't just take and say kuzobonakala phambi, But now for me, this could be one of the reasons why these people fail to call these people to order. Two, it's either they also don't know maths that well. Now, this is another issue. Now, why would you put people into those positions when they don't understand the subject as perfectly as they should? It's all because of these policies by the government that, look, if you've got one white guy, I'm going to put some controversial topics forward here. If you've got a white guy, I'm going to say it that way, so that you can be angry if you want to, or you can be happy if you want to, or whatever. Now you have a white guy who's very brilliant at this, who has proven himself. Take, for example, someone like Sir William Smith. God bless his soul. And you have a bunch of, say, 7 blacks, right? Who are not at his level, by the way. Now, you want to appoint one of them as a quality assurer, right? Now, you'll be like, okay, but there has been too many whites in this thing. Now we want to balance the equation. So let's put some blacks in there. Now, are you going to take someone who is of a meager or rather inferior quality just because of their color over someone who has merit to be in that particular position, and you're going to disregard them because of their color? And yet we claim we live in a democracy. That's ridiculous. It's absolute rubbish. Because in my opinion, the white guy should get the job. The black dudes must just go and be uplifted some way. In fact, if we're smart enough, we can actually appoint one of them to be the deputy to this one so that they can learn from this one. Because, I mean, that's what you would do. You pick the one who's maybe trying the best or who's much better than the rest. You take them under the wing of this guy, under the leadership of this guy, so that they can see how things are done. All right? That's just my opinion. Again, the other issue here is this issue of gender equality nonsense. In my opinion, if we live in a democracy, guys, we are all human beings. There are certain gender roles, of course, that we have to play, that you can duck around it all you want. It's never going to change. Between a woman and a man, the one who gets pregnant is a woman, and there's no excuse for it. It's nature that decided it. Okay? So whatever you want to say about it, it's up to you, but you can deny it all you want. A woman is always the one who's going to fall pregnant, and the man is always going to be the one to make a woman pregnant, because a woman cannot make another woman pregnant. It's just as simple as that. So now here's what I'm trying to say, guys, is that now we have started this nonsense of saying, now if you've got, say for example, a man who's competent, it doesn't matter of what race or ethnicity for that matter, and now you've got all these women here who are nowhere near close to that man's ability in doing the job properly. But now they will pick a woman in the name of having a woman there just to balance the equation. But now they're picking the mediocre ones. Because here's the problem. Between that man and these women, who was better for the job? It was the man. So why not give the man? Because if these women actually wanted this job, they should be at the level of this man, if not beyond the level of that man. Because guys, now we should not be praising people for just being who they are, as in naturally. We should be praising people for what they've accomplished and what they can deliver for us. It has nothing to do as to who they are, what they look like, what language they speak, what gender they are, which country they came from. It's all about, are you a person fit for the job? If you are fit for the job, we put you through the test, you pass it, we give you the job. But again, even if we give you the job, we still need to check you and evaluate you continuously. The fact that you've proven yourself yesterday, you can let your guard down and fail us dismally. So we can't allow you to be like that. We need to keep you on your toes. So we need to keep checking what you're doing and how you're doing it. And this is why, guys, we cannot relax, because these kinds of questions are very good questions. Don't think I'm saying anything negative in this regard, but they are not properly designed. As a result, they can put off a student, and a student may end up not scoring the marks that they could actually score, because now they are failing to understand any sense in this question. So guys, be very careful, man. Let's do the job right, and let's get the right people to hold the positions of leadership. It doesn't matter who they are and where they come from. If we are saying we're in a democracy, only meritocracy should be in controlling the systems, because everything must be based on merit. Even then, we cannot just say, since you were put on a particular job on merit, you're not going to make a mistake. If we select you as an examiner, it doesn't mean what you submit is correct. Even if it is correct, but it can be controversial. We need to stay away from issues of controversy when we're doing standard examinations. Yes, you can create a tough question, but it must not be controversial. Because if it is controversial, then it's problematic. Okay? And anything problematic, we should not entertain for a standard examination. Anyway, guys, whatever you feel and whatever is your take, but my take is that this is wrong. the way it's put, because it doesn't make sense. Although we can force it to make sense. But there are many ways, of course, of killing a cat, guys. But sometimes I wonder if these are the ways that these things have been thought of, or is it just a coincidence? Now, 2.3 says, okay, this is a quadratic sequence. We can see the flaws in the construct of this question. Now, it says, show that the first three terms, can you see? The first three terms of the quadratic sequence are given by. Remember, the first term should be the first sum, and the sum of the first term is just the first term. But now we should be seeing 1 at the top to know that we are summing the first terms of this pattern. But now this is a 0 term. Now can you see the 0 term? There's no term 0 in an arithmetic sequence. And as a result, the sum of the first term should not, can you see this gives us -2 because somebody just decided to substitute a 0 there, and then 6 minus 2 is, in fact, this is even not working. Yeah, actually 0 there, we just remain with -2. But now this is not representative. And can you see the mark allocation is suggesting that probably the technique here is to say P1 is going to be the sigma of 1 minus 1, and from 0 of 6 into n minus 1. And then P2 is suggesting that we're going to have the sigma of 2 minus 1, and something like this. Okay, so basically this means P2 of the quadratic sequence is essentially the sum of the first term here. But do you realize now what's going on in here? We have a bit of a problem. This is the second term of the quadratic, but this is the first term of the arithmetic. Can you see the mismatch? So this technique is failing dismally. And yet you can see that this is how this first question was meant to be answered. Because if you just skim the second question, it says determine the general term of the sequence in the standard format. This is already suggesting that we will have to take the sequence from there and work it out the standard way. But already we can't do this because this doesn't make sense anymore. Okay, guys, so this is why I'm making the noise. But now let's just forget the noise. We know that for 2.3 we were told that P sub k here is the sigma of k minus 1 starting from 0, 6, n minus 2. Now guys, here's what I know. This whole thing is a sum. Right? This is a sum. It's the sum of all the terms. Sum of all terms in the sequence. Right? Right. So how do we deal with this? We do it as such. In my opinion, we can just express that P of k, or P sub k, not P of k, but P sub k. P sub k, or pk, carelessly, but this is a subscript, please remember that. Pk is more like P times k, but P sub k means, it's a subscript. It's the kth term, meaning any term in the sequence. Now let's see. Pk, remember the sum here. The sum in this case is suggesting, guys, that we need to expand this to 3 terms at least so that we can understand how to do the sum in there. You get it? So this is essentially 6 into 0 minus 2 plus 6 into 1 minus 2, right? Then plus, we need 3 terms usually, but again, I know that the common difference is going to be the coefficient there. So sometimes I don't even need many terms. And then this goes on until we've got 6 into k minus 1 minus 2, right? this is what this means. This is essentially what this means. And of course, we can simplify further and say P sub k is, now we know that this is the sum, and of course here we get what? Minus 2 plus, this is 6 minus this is going to be 4, and then plus dash dash dash, and then this goes on up until we have the last term. But now I'm not interested in the last term. I mean, you can put it if you want. It's not a big deal. It's not a big deal at all. We can simplify this perhaps and say the last term here is going to be 6k minus minus 6 minus 2 is going to be minus 8. Okay, so this is the last term. So one can think of it this way. And since we know this is arithmetic, because we know that the common difference here is going to be 6, whether you do it again or you just take it from there, it's not a big deal, because we already knew this is what this is going to be. So we can say safely, guys, that essentially this implies that P of, not P of, but P sub k is, in an arithmetic, we know that it's going to be the number of terms. But now the number of terms is what? Is the top minus the bottom plus 1. So that's another thing to note, is that n is going to be k minus 1 plus 0 plus 1, which is just k. So we know that the number of terms here is going to be k divided by 2 into the first term, which is minus 2, plus the last term, which is 6k minus 8. Now we sort it out and say this implies that we have P, come on man, P sub k is going to be k over 2 into 6k minus 10. Now when we distribute, we can see that P sub k is basically 6 divided by 2 is 3k squared minus 10 divided by 2 is 5k. Now that we have this, we can say therefore we know that P1 is going to be 3 into 1 squared minus 5 into 1, which is equal to, now this is 3 minus 5, which is minus 2. Therefore also P2 is going to be 3 into 2 squared minus 5 into 2, which is, now this is going to be 4 by 3, that's 12. 12 minus 10, that's a 2. Okay, so that's a 2. And also, therefore, P3 is going to be 3 into 3 squared minus 5 into 3, which is, now this is 9 by 3, that's 27, minus 15, that's 12. Okay, so this is the best way for me one can show this. But do you see that this is not 3 marks? Because without doing it this way, it does not make sense, guys. It doesn't matter what anyone thinks about it. It just doesn't make sense. So anyway, guys, so this is it. And maybe if you like, you can now write that therefore the quadratic pattern is such that we have minus 2 to 2 to 12, and it's ongoing. Maybe that would be the final answer in this question. Okay, however you see it, guys, but this is how I would go about it. This is how I would go about it. And then of course here, guys, I used this formula that Sn is n over 2 into a plus the last term. This is the formula motivating all my actions. But because it's too complicated at the moment, I just went with it just like that. Actually, this should be the one that is here. So this is essentially my big reason for what I wrote. Sometimes in maths you can be creative, man. Present your stuff in a nice way and say this is like that because of this formula. Now you understand, or you can write the formula first and then write this down. But sometimes, just for the sake of continuity, it's nice to just leave it as a reason, be flexible. So we have shown indeed, guys, that these are the terms. Maybe it looks like the examiner is saying you're only getting these marks. I doubt, because these have been given. So in my opinion, I would say, okay, all right, okay, the correct substitution into the correct formula for me makes sense. And essentially getting this formula, because this is what matters, maybe that's the second mark. And then say all these substitutions, that's the third mark. And since this has been given, but again, guys, this is mean. This is mean, okay? If not mean, it's really stupid. Okay, sorry for that, guys, but yeah, whatever. So this is 3.1. So let's say 2.3. Then we've got 2.3.1. Nice. So we've done it, guys. However, this question is unfairly created. So 2.3.2. Now it says determine the general formula of the quadratic sequence. Write your answer in this form. Can you see, guys? We already have it here. Now the question is, would you get 4 marks if you just plug that answer there? The answer is no. There's no way. Because here is the issue, guys. This was not the case. But now, I don't know. But you know what I would do? I would just write here and say P, because I'm a brave student. I was a brave student. I would say P sub k here would be 3k squared minus 5k. And that's it. And then I would say C above in 2.3.1, because I've done my workings. And you can clearly see here that there's more marks I can get. First of all, I get a mark here. Again, for pointing that out, even though I got a mark here. But remember, for the number of terms here, I would still get a mark, because that's very important. And for spotting the common difference there, I would still get a mark, because it was not clearly given, but I had to decipher it. So let's mark those differently instead. Let's mark them differently so that you can know how these marks could still be given what you have just done. So this mark would be for this, for knowing the number of terms in there, right? And then we can safely say, essentially, maybe not there, but here. And then we can say here again, for the common difference, that's the third mark. And essentially the correct substitutions, because this would be a calculation on its own. Even though the correct substitutions and the formula have been marked already, but I suppose they should be marked again. You understand? So this is how 4 marks could still be given to you, provided you write this statement. Of course, guys, ask your teachers if this is acceptable. Ask your subject advisors if this is acceptable, because some of them are very stiff. They are not flexible because they don't understand the subject so well. They think everything has to be like that, okay? Alternatively, to avoid controversy, this is what I suppose should be done. We know that the quadratic progression is -2, 2, 12, and then it keeps on going. Since we know what it is, we can work through it. So this is 4. So this is going to be 10. And this keeps on going. And we know that the common the common difference here is going to be 6. It doesn't matter that we don't have as many terms to see that this is common. The fact that we understood, we were told this is the quadratic progression. So this means it's going to be the case throughout. Okay, so we know that essentially 2a is going to be 6, therefore a is 3. This implies that 3 into a, which is 3, plus b should be equal to 4, therefore b is, now 4 minus 9 is minus 5, okay, which also implies that a, which is 3 minus 5, plus c should give us minus 2, and therefore our c is 0, because this would be minus 2 plus 2, which is 0, therefore pk is going to be 3k squared minus 5k. This is the non-controversial attempt in just staying away from trouble, because here it's easy. These values are key, and that's how the 4 marks can be scored. And I suppose students should present this answer for this question. Even though it looks like nope, we are actually repeating ourselves, but unfortunately a poorly designed question is bound to show up like this, because for me this way of presenting the first 3 marks is the only sensible way, because any other way doesn't make sense, unfortunately, unless you have something else to tell me. Of course, guys, I don't understand the subject better than your teachers. Maybe let me refrain from saying what I'm saying. Just show you guys what to do, try and stop there. Maybe that's what I should do. Anyway, guys, so this, I suppose, is the best way to see these 4 marks. But for me, if you write the answer and you say C above, there has been quite a lot of workings. There can be areas to give marks for this, you know. There can be areas. In fact, here, instead of giving the mark here for that, for example, the substitutions again, because we marked it already, we can just mark it for this sequence, just expanding the sequence. The expansion sometimes can be marked, so this could be the mark right there. See? Not too difficult to find a way, because sometimes how you answered the first question may just be because, nobody said how, so you saw that is the way, and that's the best way, by the way. Anyway, let's go on, guys. 2.3.3. we need the 50th term, so we know that p sub k is 3 squared minus 5k. So this implies that p sub 50 is going to be 3 into 50 squared minus 5 into 50. Therefore, p 50 is 3 into 50 squared minus 5 into 50 is this is 7250. Okay, for me guys, this question I would disregard, because this has come out already up there, in my opinion, because that's the only sensible way to go about this question. I would probably disregard this question and perhaps just shoot for this one instead. That's another way this adjustment could have been made, seeing that there's a bit of controversy going on in there, unless a student chooses a different path, of course. Anyway, anyhow, substitutions answer is usually the way forward, because again, it's very difficult to know what to do here if you're not so sure. So we must use a formula, so it makes sense to use the formula. Okay, let's do the last question. It looks like we're going to run out of space. 2.3.4. now this is the suplexity, guys. This is getting suplexed by the animal. Anyway, it says the number of terms that must be added. See, number of terms that must be added to P50 to form, can you see P50 that we calculated here, to form PQ. Now this is another term in the sequence, is M. Now M is the number of terms. Remember that. Okay, but now which terms do we add to P50 to get another term in the sequence? Do we add the quadratic terms or is it something else? Now this is where your analytical mind needs to really come to its fore, because I don't teach you guys these things to clown around. Let's start. What was our quadratic here? We understood that we started at -2. We started at -2. Quadratic pattern started at -2. We went to 2. We went to 12. Now we went all the way to term number 50, which is 7250. Okay, and then this keeps on going. Now we know that this is term 1, term 2, term 3. Since we're using the P here, let's just use the P and say this is P1, P2, P3, and now this is P50. We know this. And of course, we will be doing this. Say this would be essentially 4. Here we would get 10. And then this is a sequence, right, that keeps on going. And here we get 6. Again, this is ongoing. Now, we know something, guys, that here, between this term and the next term, we would get a particular term here. But now, what would that term be? What would that term be? This term here, we can call it Tn. But we know, guys, that, do you realize that this P1 went straight to P1 of the first differences? So if we've got P50 right there, that should be 50 as well. So that should be T50 of the arithmetic sequence. That's what we know. Right. So again, we know that technically, if we think about it a bit more, we realize that from the first term to the next term, we added the first term of the first differences, right? We get that. That is a 2. But to get the third term, we added the first term to the first term of the first differences. And we also added this one. So we went like so. And we added this term as well. Because -2 plus 4 plus 10 gives us 12. So actually, the terms that are being added to the first term to get every other term in the sequence are these terms right here. These are the terms that we're adding. So this means also to this P50 that we are being asked about, we are going to add this term number 50 and every term that comes next. Right, these are the terms we will be adding. The number of terms that we will be adding to P50 so that we can get to that PQ. So again, guys, these questions, if you don't understand the construct, or at least you don't understand these sequences, as I told you, if you don't sit back and study these things after solving, you think just by solving you know the math, you are ridiculous. Let me tell you now, you are really ridiculous. You need to think again. You start learning how to solve. That's a means to an end. But do you even understand what you have? Can you make a sense of every situation? Remember, as I said, at times you will not make this up in your mind. You're not ready for it. You see it in the exam because the students who wrote this paper, They met this thing in the exam for the first time, and I believe this must have been the hardest question for them. I doubt if many actually answered it, although they knew. Of course, some students know that even if I cannot show that those are the terms, I can take those terms and answer this question and answer that question. So these 6 marks they could still get. But I doubt they would know how to solve this. I doubt they would know how to do that effectively if they didn't think about it the way I have shown you, because it wouldn't make sense by just substituting the values here and seeing what you need. It's very dangerous. So guys, this means to P50 we're going to add the first differences starting from term number 50 of the first differences. Now as we add each consecutive term to this one, it will end us up there, because we saw the same thing. We took the first term right here, we added the first term of the first differences and the second term of the first differences, and that gave us the third term. Or we just added the first term, it gave us the second term. So this is exactly how this works. Again, you would have to have understood how these things work, and you would never understand how these things work if your awareness is dead. Again, you need to understand the question. You can't just look at the question and have an answer. It taxes you, guys. This is why this is a higher order question. Anyway, let's stop preaching now. We understand what we need to do. Let's just sort it up. So here we want these ones up until Tn, right? Whatever that Tn is. Because once we add these, they will give us that. Because eventually, the previous term, adding that Tn to it is going to end us going there. Or we can easily say this term plus all these terms over here will take us right to the P50. That is the question. Alright guys, so now that we understand what we need to do by just studying this portion, because remember again guys, what you have to study it. If you don't understand or you don't get the idea straight up, just look back and say, from this, what can I learn so that I can use the same idea in the next one? Because you're not always ready. You just always have to look. This is why I taught you the sequences and series the way I did, so that you can learn how to look at what you have and find a way of solving the problem. Anyway, guys, let's go for it. And of course, we know that here, again, there's going to be a common difference here of 6. It still doesn't change, right? It doesn't change because it's coming from all the way there. And it's still going to keep on going all the way there. Now that we have done our groundwork, now let's start answering the question. What does it say? We are adding this number to P50 to get P4. So basically, guys, we are saying here P50 plus SM. Why are we putting S sub M? Because M is the number of terms here. Remember, M is the number of terms. So this should mean S sub M. And guess what? What terms are we talking about? It's going to be the arithmetic series, or the first differences, starting from term 50 of those, because this is what we will add to this P50 to move forward to the next ones. So this is going to be equal to, we are told it gives us PQ, right? Or we can easily write it the other way around and say, perhaps it's best if we say P sub Q is going to be P50 plus S sub M, because that's the number of terms. And now we know that this sum is those terms right there. Okay, so this implies that PQ is basically P50. Now we know what P50 is 7250 plus, now S sub M is a bit of a challenge now, because we first need that P50, right? we still need the P50 of the arithmetic series. Okay, all right, okay. But what we'll appreciate is that that general formula right there is actually these ones. Let me prove it to you. Tn of these ones is going to be 4 plus n minus 1 times 6. This is 4 plus 6n minus 6. This is 6n minus 2. Can you see? Now, how would it make sense if you were saying here, you're just adding only these terms to get the quadratic? It doesn't make sense. So an adjustment was needed to be made here. So we know that this general term technically is this one. And can you see? This is that sequence right there. My Lord. The examiners babapala diketo karuna mona. So we know, guys, that technically this is going to be the sum from this term 50 of the arithmetic sequence. But now I'm going to do it in a smart way because I don't have time. You know, Mos, I'm the guy with the ideas. So, by the way, what do we know, guys? We know now that this is going to be the number of terms. It's going to be m over 2. Remember, this is arithmetic. Into, now this term right here, term number 50 is going to be 2 into, we're going to have 4 plus, if this is term number 50, it's going to be 49 times 6. Now I'm moving quick because I don't have time to play. Now remember, we're going to say plus. Remember that was 2a. So this is going to be essentially, this is going to be m minus 1 times the common difference, which is 6. Okay, again, we know something, that this is because we know that Sn is equal to n over 2 into 2a plus n over. Okay, now we know that S sub n is equal to n over 2 into 2a plus n minus 1. D. Okay, so I'm trying to use it as a reason, folks. Whether you like it or not, you will see it. It's there. Yeah, as well. So again, I'm using it as a reason because I'm trying to run away. Of course, you could easily do this separately, but if you noticed, it's that. Remember that P50 is already there. We know from above. We could easily just decide to take it from here. We could easily decide to take it from here. That would be 298 because we can see the similarities. Again, it means being aware is more important, but sometimes it may feel like I need to calculate it. But this is what it is. Okay. So this means PQ is equal to 7250 plus m over 2 into, now we know this is going to be nothing but 298 times 2. Sorry. What is in there? It's 298 by 2. 2 times 298 is 596. I'm trying to avoid doing too many steps. This is 596 plus 6m minus 6. All right. Okay. All right. Now, guys, we just keep going. Questions like this need you to be systematic and meticulous because, yay, uzova uyasha ubeso wenzani bese uyashabalala. So this is 590. Okay, let's conclude this business. Therefore, PQ is equal to, so this is 7250 plus, now let's see, this is gonna be 3m squared minus, let's say 590 divided by 2, it's gonna be 295 m when we sort that bracket. Again, guys, now it means you need to be strong by the time you do your trials to do these simplifications as best as you can while being meticulous. Okay, but now we can see this is a very nice quadratic, so we can write it in standard form, right? We can write it in standard form and say, okay, you say must come up this side, these ones must do it like so. Okay, you are supposed to be there, okay. So this is how we want to do this. Some people would choose to say this is equation 1 because, again, this uses the concept of simultaneous equations. But can you see how tough it is to set it up and to go with it? It's quite challenging. But let's have a look. What is the next statement given? Now, the difference between P50 and PQ of the quadratic sequence is this plus. Can you see? Obviously, if this is a term ahead, this PQ must be bigger. We know that also PQ minus P50 is going to be 7920 plus M. Okay. And therefore, this means P sub Q is, we transpose this, it's going to be 7920 plus M plus, what is P50 there? We saw that it's going to be 7250, because this is the quadratic sequence, right? Right. Because we're told that this is of the quadratic sequence over there. All right, okay, all right. So essentially, guys, what are we going to say? We can sort this up. These are like terms. We can add them up. So 7920 plus 7250 is essentially M plus 15170. Okay, so folks, do you realize now that we are defining P sub Q? So these are simultaneous equations. So we can say then, we know that this shenanigan, 3m squared minus 295m plus 7250 is equal to m plus 15170. Easy, because we know that essentially equation 1, maybe we can call this equation 2. We know that 1 is equal to 2. If someone is asking, but this is quite obvious. So we write our quadratic in standard form, 3m squared minus, so this is going to be 296m minus, because this is going to be a bigger number, 15170 minus 7250 is 7920 equal to 0. Now question is, can this divide 3? Let's check. Let's see this last one. Yes, it does divide into 2640. Let's take this one, 296 divided by 3. This one does not. It is not doing it. It is not doing it. Did I make a mistake now? Hona le bothata na ha ke le ndwetseng. because this 296 doesn't divide 3. Now I'm thinking, did I make the right things there? So this is 4 plus 49 times 6. It's 298 times 2. That's 596. So this is correct. Minus 6 is 590 divided by 2. It's 295. Okay. But now, here's the question. This was not negative. This was not negative because remember, this is positive, so this is not negative. So my problem here is my sign. Okay? So my sign was wrong. So be careful, guys. When something doesn't gel, when it seems to be gelling, you will see that there is a mistake in your business right there. So this is plus. Now when we bring this one, it becomes 4, not 6. Okay? All right, so let's see. But again, it's positive, hey? The sign, guys. Okay, now we are good. Looks everything is fine. Let's say 294, does it divide 3? Yes, it does. 298. Now we've got just m squared. Okay, this is equal to 0. All right, guys. So, I mean, at this stage, students feel punished enough. They would want to cry and, give up the ghost and say, me, guys, I always know how to factorize this thing, so I will always attempt to. Now, all I have to focus on is this dude. So let's see, 2640 is the same as what? So I'm gonna shift fact that thing. Shift fact. So I'm getting a very interesting expression right here. So this is 2 to the 4 times 3 times 5 times 11. Now I'm the guy who always knows how to do things. Now, can I say 5 times 11? Let's see, what do we get? 5 times 11. It gives us 55, okay? And then what is that? This is 16 times 3. That's 48. Now that cannot give us 98, so it's not going to work. Lord. Can we say 3 by 11? That's even smaller. That's 33, right? 33, and then we can say 16 by 5. That's 80. Again, it doesn't give us 98 because it's a difference. So it means we need to break this power. This power must be broken. Of course, now here's the method to do so, is to do it sequentially. So we can say here, this is 2 times 2 cubed times 3 times 5 times 11. Don't always break it to the ground initially. Just do it sequentially and see if it works. Now we've got, let's see. Let's see, what if we say this and this? Huh? Mark. 2 by 11 is 22, right? Now let's see what happens with these ones. What do we get? I think it's gonna work. So this is 8 times 3 times 5. My goodness, what is this now? 2 cubed is 8 by 3, 24 times 5. 24 times 5 is just 120. Okay, so that is 120. Okay, it works. I was worried now it's not working. I actually didn't write the 2 cubed. Okay, so 120 minus 22, it's 98. Definitely it works. So again, guys, you may not want to go through this torture and just plug into the quadratic formula. I can already see 120 needs to be the bigger one, and then this one is the 1. So therefore m should be 22, because this is going to be negative, so it's not allowed. Why? Because m is the number of terms in a sequence, and m should be an element of natural numbers. This is very important. Okay, so we can say therefore 22 terms must be added here, because it says determine m, so I mean we don't need to worry about it. We know m is the number of terms, and it said find m. So you can see, guys, this is not a joke of a question. It's a hard question. It's taxing. It's taxing. So obviously, guys, if you noticed, this came from above 298. So you would know that you don't need to go through the process. Sorry. So essentially, guys, in my opinion, all these substitutions is a mark, right? Getting this equation is a mark, and this equation is a mark, 3 marks. Now equating the 2, 4, finally the 5th mark, because every other method was just a means to an end. And then of course, guys, if you're not so strong to know how to deal with factorization, just use the quadratic formula. But hey, this was a rather painful 5 marks, I suppose, but it's worth the practice right now, because I'm not in the exam now. Alright, guys, so this is essentially how tough these questions can be. And as you can see, this is a true higher order question, because you needed to understand the construct of a quadratic pattern, how things are related, and what should be added against to what should not. Because we normally don't add the individual terms to get another term, but we add the terms in the first differences. And that's what needs to be clear. And we get to the answer. As much as the question was poorly designed, but it could be answered. So again, remember, when something doesn't make sense, it doesn't mean there's only one way you can look at it. Try to find a way that makes sense and go with it and see how far it takes you, because giving up is not the goal. Okay, guys, I made this video too long. Let's do question 3 quickly without wasting too much time. Now, this is slanted. Hate it like this. Now we're told here, a sightseeing point is built by placing concrete cylinders with a height of 0.2 meters. Okay, so this is a concrete cylinder, something like this one right here. So understand the patterns, folks. From grade 11, you've been doing a lot of these patterns. So this is the story right there. I don't know why I didn't just quickly do this, but yeah, whatever, guys. At times you just show the things that must be shown. So this is the cylinder, and we are told that the height from the top to the bottom is 0.2 meters. And of course, this is going to be the top of the cylinder. This is the top of it. Okay. This is the top. Great. And of course, this is the next cylinder. I'm not going to go through it the same way. So this is 0.2 meters. And we know that this would be its top. Okay. And then this is another cylinder, which is 0.2 meters. And this is the top right there. All right, so this is cool. So we are told that, okay, the radius of each consecutive cylinder is 4/5 of the previous cylinder. Okay, so that means we just multiply that previous radius by this. Now, can you see this is a geometric, because the moment we have a common ratio, that's done. So it says the radius of the cylinder at the bottom is 15 meters. So we know that, okay, from center to circumference, this is 15 meters. So essentially, if we're looking at the radii are going to follow this pattern, 15, and then let's do 15 multiplied by 4/5. That would be 3 by 4. That's gonna be 12. Okay, let me just check. Yeah, that's 12. So that means the radius of the next one is 12, and then the radius of another one is gonna be like that again. 12 times 4/5. Now this one is 9.6. Okay, this keeps on going like that. All right, okay, all right. So this is just the sequence of the radii. Let's say sequence of the radii. This is what we have. And we know this is geometric because the common ratio here is 4/5. Easy stuff, easy stuff. So these kinds of things, guys, need to be realized. And you know this is going to be very useful. Now the question says, John is standing on the 17th cylinder. Calculate John's height above the ground. So John is on the 17th cylinder. And now we need to calculate his height. Of course, guys, this is the first, second, third. Now on the 17th, this is just 17 times this. So this is very easy. 3.1. We can say John's height is going to be 17 times the 0.2s, because this is not really difficult. It's as simple as that. So 17 times 0.2 is basically 3.4 meters above ground. Okay, all right, okay. So we are sorted right there. Because, I mean, guys, this is simple because this one is repeating itself. So this is number 1, number 2, 3, and then we keep going. And so we can see these heights. It's just this height plus another height plus another height. And so he's just going to be that above ground. We're not asking about his actual height as in himself. All right, okay, all right, guys. This one was simple, 1 mark. 3.2 says, calculate the volume of the 17th cylinder. Okay, guys, so now for us to know the volume, we first need to know what would be its radius, right? Right, because without the radius, we are dead, are we not? So first of all, we can say the radius of 17th cylinder would be such that Tn is equal to Arn to the minus 1, because we saw that the radii are forming a geometric pattern. So that means T17 or T sub 17 here, it's going to be A, which was 15, into the common ratio, which is 4/5, to 17 minus 1, which is nothing but 16. You can say therefore T17 is 15 into 4/5 all to the exponent 16. So this gives us a 0.4222 meters. Because this is the radius, isn't it? Now we can just cut it off, or we can leave it like this. Sometimes I think this is fine. Sometimes this rounding off business is a bit dangerous. Sometimes we can leave it here and just say this is it, because we don't want to complicate our lives by rounding off already. But now we can say then volume is going to be, remember, for a cylinder, it's going to be the area of the base, right? Right. And the area of the base is going to be pi r squared times h, which is the height of the cylinder. Now, which is going to be equal to pi into what is the radius, is exactly what we have found. So the radius is a bit complex now. So this is 15 into 4/5 to the 16. We can simplify it now. And then we are squaring this and we are multiplying to this. The height, remember the height is still 0.2 because the height is the same for all. Now all we do, we just say shift pi, open bracket, 15 into 4/5 to the exponent 16. We close this and then we square it, and then we multiply this by 0.2. So the calculator can handle this. So it gives us that the volume is 0, now to 2 decimal places is 11 meters cubed. Okay, very nice question. A bit challenging. A bit challenging. Because remember, that would be the radius. Okay, great. Again, guys, you need to know this formula. Can you see, even when you're doing sequences and series, you think you're only going to come across this in calculus. Yeah, it comes in calculus, but it comes here too. And you can see it's just 3 marks to show that it's not really that deep. First of all is finding the radius, right? Then correct substitutions and the answer. But remember, the answer must have the correct unit. The correct unit of measurement is neglected. The final answer loses its mark. So 3.3. It says calculate the volume of the concrete that will be used to fill the 17 cylinders. Now this is going to be a bit of a situation, right? Yeah, it's one of those questions now. So basically, guys, to find the volume of the concrete that will be used to fill these first 17 cylinders, it already tells us that we certainly need to use the sum of the volumes now, not just the sum of the radii, but the sum of the volumes. You understand? And so now it's a little bit interesting in that we know the sum, but now we first need to think about this. We can say the volume, the sequence of volumes, is such that the first volume here is pi r squared. So it's going to be pi. R was told to us that it's 15 squared times 0.2. And of course, remember we're doing the sum now. So we're going to make it a series. So this is going to be pi. The r of the second was 12 squared times 0.2, right? And then plus. Of course, guys, we know that this is going to form a particular pattern since the radii were related in a particular way, and so will be the volumes because they have the radius involved. So we can safely say this is going to go on up until we have that 0.11, which is the last one. Okay, all right. And we know that we've got how many terms here? 17 terms. So this is easy. So we just need to find out, is there a common ratio? If there is, what is it? Obviously, it's going to be those of the radii. It's going to be those of the radii because everything else will divide out nicely, leaving these ones. So we can say R here is essentially pi 12 squared times 0.2 divided by pi to 15 squared times 0.2. And of course, the 0.2s and the pi's will do their own thing. And all is left is for us to handle the business now. So let's say 12 squared divided by 15 squared. We get 16 over 25, okay? And then, what do we do now? We know that there's going to be a common ratio because the only thing that changes is going to be this, okay, guys? But you can do the next term, if you will, and see if the common ratio is the same. It should be. Let me just check in case I run into the problem. So we saw that the other one was going to be 12, one was going to be 9.6. So let's see that we will have here pi into 9.6 squared times 0.2 divided by pi into 12 squared times 0.2, and those do it. So let's see what happens when we have 9.6 squared divided by 12 squared. It's 16 over 25. So indeed, we are not bluffing, but in case you're not confident, you may want to do that. So guys, this is the common ratio. So we can see that this still forms a geometric sequence. So we're just doing the sum. And since we have 17 cylinders, so this is a finite, it's not a sum to infinity. So let's see, we know that then Sn is going to be essentially this 16 over 25 is less than 1, right? 16 over 25 is less than 1. So if it is less than 1, we use that formula that it's going to be A into 1 minus R to the N all over 1 minus R. Okay, so this implies that S sub 17 is going to be the first term, which is going to be pi 15 squared times 0.2. Yeah, this one is a crazy thing, you know. It's going to be 1 into 16 over 25 raised to the exponent 17, all divided by 1 minus 16 over 25. Okay. Now, I don't like to write my answers like that, but due to space, I'm going to force it there. So let's do this calculation, as crazy as it is. Pi into 15 squared into 0.2. That multiplied into 1 minus... But our calculators are the smartest, you know. This Casio is the best. I actually used a Casio. My sister-in-law actually bought me a Casio in my matric year while everyone was buying the Sharp DAL calculator. I was bought a Casio, and man, it was a beast. What that DAL couldn't do, my Casio was just flowing. Little did I know that the future of these calculators is going to be the Casio over the DAL. Anyway, guys, here is the concrete. I don't know if this answer is correct, but guys, it's complicated. So this is 92 to 2 decimal places is gonna be 50 meters. Remember, if this is the volume, this should be cubed, and I was wrong here to write squared. This is cubed, so be careful. You see, sometimes you may forget up there, then you remember. So we can ask now, it says the volume of the concrete needed. Oh, jumping at it, and we can say therefore the volume of concrete used is 392,50 meters cubed. Okay, so that becomes the 8 fancy mark of this question. Of course, it was not so nice, by the way, but it's doable. First, finding out was key. Correct substitutions into a correct formula, that's a mark. And answering the question eventually, that's a mark. And essentially knowing that the first volume is going to be that's the other mark. So that would be the 4 marks of the question for a total of 8 marks. Okay, not too complicated, but it just needed one to understand how to set up that question. Not so easy to just rush through. Definitely something to consider before you move on. I cannot speak of the complexity of 2.3.4. This one is it's probably even worse than complexity. It's like Goldberg handling you in the ring, okay? Giving you a spear and a sledgehammer. A whole lot of other things. Okay. Anyway, folks, I hope you've enjoyed the video, and I'm gonna just stop here and not rant any further. I've given too much rant and the video has been longer than it's supposed to be. But remember, guys, when you are practicing, you're not gonna be doing time attack. You just want your solidified approaches, displayed before you. You want to see if you are capable. Give yourself time to do this. Then when you feel you are confident now, you feel like, okay, I can figure out a lot of basic questions or standard questions. Then you start doing a time attack. Now, usually that is appropriate when you're getting ready for the exam. And remember, getting ready for the exam, you shouldn't be studying for the first time. You shouldn't be practicing for the first time, because obviously, guys, you're not going to be able to succeed in time attack that way. Because remember, that would require you to study a whole lot of volume of materials. And it would require also for you to spend a lot of time trying to figure out some challenging situations. At the end of the day, you would give up and say, I don't know this. And unless you are lucky in the exam, the section is asked in a very easy way that you can follow. But what happens when you are given a question like this? The structure is horrible. The structure is horrible. It's not exactly representative directly, but indirectly, when you start knowing what to do, you start to see exactly where this takes you. And you just keep going, and you keep going, and you keep going, and you keep going. You get it. You get it. Yes. So, and at times you get technical questions like this where you just have to think about it. You have to think about it. And I'm glad that those in the Northwest who wrote this paper and did the remedial work with their teachers, that question in the final exam is similar to this. They must have cruised, because you just can't get the exact same thing, but it was the similar idea. So it should have been easy. Anyway, guys, this is it for me. In fact, I just wanted to go back to saying, look, because this design was not as perfect as it should be, or at least in the manner that it was put, why did it work? Why did it work? Remember, look at this sequence. I'm just going to highlight this. If we look at the quadratic sequence, this is minus 2, 2, 12, and so forth. And we saw that the first difference was 4, and then we saw that the first difference was 10, and so forth. Okay, remember, as we just said now when we started answering this question, if you look as to why this general formula worked, but again, they needed to make sure they adjust things here properly. If you want to say, I'm going to the next term, I'm going to take this term and add this term, and then I'm getting that term, right? So as you can see, if you just take this term and keep adding these terms, you will keep getting the quadratic terms. So actually the new sequence now is starting to look like this. So the new sequence is basically minus 2, 4, 10, dash, dash. And can you see the common difference here is 6, 6. And this is why the general formula here actually worked. Because now you would be like t, and because you can see this is now arithmetic, it's going to be minus 2 plus n minus 1 times d. In fact, why do I even waste time now? So this is minus 2 there, and then we saw that this is 6. But it's slightly different anyway. You will see minus 2. If you do this correctly, this gives us 6n minus 6. Therefore, we get 6n minus 8. Can you see, this was supposed to be, actually, now I'm starting to think this is probably the adjustment that should have been made. Because if this was the general formula placed in there, it would make a whole lot of sense. Because here we could start from term 1. Right? Because now it would make sense. Let me just put it to the test, guys, just to see some of the corrections that should have been made anyway. Let's say now we had, this is n starting from 1, right? And we have this general term here. And here we could decide now that we are going to say k. Because k is what we wanted. Let's say pk was written like that. What would be the case here? If we expand our sigma here, we know that when we put 1, we get 6 minus 8, which is minus 2, right? Now we're just dealing with this with the series first. We're not caring about other things. We put a 2 there, that's a 12. 12 minus 8, it's a 4, right? And then we go on and say, we put a 3 in there, that's 18 minus 8, that's a 10. And then the series keeps on going until we substitute k. Now we don't care. Now let's say we want the first term here. Can you see this would make sense now when we say P1 is equal to K, where K is 1. So it's going to be the sigma of 1 of n equal to 1 of 6n minus 8. Because this simply means we are just summing up the first term. And the first term is indeed the first term of the quadratic sequence. And when we say P2, we're just going to say P2 is going to be 2 sigma from n equals to 1 of 6n minus 8. And guess what? This would mean we are summing up the first 2 terms, because this is going to be 2 minus 1 plus 1, which is 2. When we're summing up the first 2 terms in this arithmetic series, guess what? Minus 2 plus 4 is 2, which is exactly that term right there. And then we go again and say the third term. The third term would be, again, we say P3 is going to be 3 over, sigma from n equals 1 of 6n minus 8. Remember, we put the sum of the first 3 terms. Now, this is going to be the sum, essentially. Minus 2 plus 4, that gives us, essentially, 2. 2 plus 10, that's a 12. Can you see that's that term right there? So actually, the best way that the examiner should have written this was like this. Now, a question can be made very interesting if only people understand what they're doing. But when they don't, they fool around. And unfortunately, people don't ask questions. So this is how I propose this should have been written, provided one studied exactly this sequence properly. This was supposed to be the term that was given as the general term there. Amen. So guys, this should have been what was written there instead of what was written. This was supposed to be the one, because this one would make sense to answer in that manner that was required and to go on to find the general term thereof using the standard approach. And. Because even if guys, we looked at the sum in this case, we would still get exactly what is right. Even if we decided to do the sum using this formula, we'd still get that general formula. Let me show it to you. It's going to be k minus 1 plus 1, which is 0, so there's k terms. So it's going to be k over 2 into, now we work out what would be the first term here. The first term is nothing but minus 2, right? So we're going to say 2 into minus 2, isn't it? And then plus n minus 1. The common difference is 6. It's not going to change. So this is k over 2 into, this is now minus 4 plus 6n minus 6. Can you see? Still goes back to k over 2 into minus, into 6n minus 10. Can you see the general formula would still, this time we're going to put k where n is, because we're saying k terms. So can you see it goes back to 3k squared minus 5k. We still get it. So this was the best show, provided one studied this thing before they wrote the formula carelessly. Again, this is not so bad after all, because we could see we answered most of those questions without having a trouble. But this is how things should be done, guys. Somebody must be very careful to adjust things so that when the student looks at this thing, they can see the sense and be confident to continue. But anyway, guys, this is just my 2 cents of the knowledge, and I hope that maybe it adds value if somebody takes it positively, or perhaps they can take it negatively. I'm not here to judge, but I'm here to poke holes where there are weaknesses so that we can solidify there, so that as we move forward into the future, guys, we don't lose out on bigger things just because of some carelessness that we've been exercising in our construct. We want something solid, something dependable, and something that we can be proud of in the future. Anyway, guys, goodbye. I hope you enjoyed the video, and of course, do criticize where you want to. I'm open to criticism, and in fact, I will argue my point sometimes at a point of ignorance. Please be persistent. Don't just give up because I seemed to give a bit of an argument. I remember there was a student who asked me something about the least squares regression line, as to when you actually plot it, do you go beyond those data points or do you remain at those data points? Of course, the domain is key. But I made an argument that, but for me, the y-intercept is part and parcel of the equation. So showing it would not be punishable, because in any case, those data points, that domain gives us that y-intercept anyway. So again, I wasn't exactly correct, because it seems, remember guys, even if I can put an argument, it doesn't mean it's correct. What matters is that what is the standard approach, because of course, after all the arguments we can put, once we decide on the standards, then we stick to them, whether there's better things beyond them, but because of just avoiding controversial issues like that, then we stick to that. And then the guy didn't put up the fight, he just stopped there, and yet he was actually right, because he should have said, no, the standard or the standardized approach to this, or what is acceptable, this is the one. Then that would have been very nice for me to take, because I didn't actually disregard that opinion. But I just had my argument, because at the end of the day, if you can argue your point in court, guys, even if you're wrong, it sometimes becomes considered for the next case where whatever you said actually can apply. Okay, of course, not putting a particular restriction to it. Anyway, guys, I'll see you again next time. Have a lovely one.